Welcome to this channel. If you are new to this channel, please kindly subscribe to this channel and please like and share to others. This channel is about to be teaching us mathematics, physics, and further maths, chemistries, and the likely questions to be seen in your WAEC, NECO, jobs, and the likes. So, we started the topics last week about the Venn diagram for two subsets and had made every possible things to explain the rules that guides the Venn diagrams for two subsets. Today, I'm going to be solving some questions under the Venn diagram for two subsets. Now, the first question I would like to solve today is that in a party for 30 young children, 12 were served. It is said in a party for 30 young children. That means the total number of children that were in that party was 30. What does that mean? That is a universal. That is a universal. That is 30. Universal. That's the total number of children. 12 were served Coca-Cola drinks. 12 were served Coca-Cola drinks. That is number of Coca-Cola. 12. Number of Coca-Cola was 12. Why 14 were served Pepsi Cola? 14 were served Pepsi Cola. That means number of Pepsi 14. If 9 children were served Coca-Cola but not with Pepsi Coca-Cola. 9 children were served Coca-Cola but not. What does that mean? 9 children were served Coca-Cola but not minus with Pepsi. 9. I believe you still remember the meaning of this. That is, 9 children were served Coca-Cola but not. That means they were only served Coca-Cola, not Pepsi. That means it is in C or not in P. That is the meaning. Now, but not with Pepsi Coca-Cola. Find. You have to find the number of children served both drinks. What does that mean? The number of children served both drinks. That means we are looking for number 1. The number of children served both drinks. That means intersection. C intersection P. We are looking for this. That is served both. When they talk of both drinks, that is intersections. Number figure 2, the number of children served at least one type of drinks. We're going to be seeing that when we start solving. The number of children not served any of the drink. That means not served any of the drinks. That means the last one says the number of children not served any of the drink. That means it's not existing here, it's not existing in two subsets. So it's existing outside the two subsets. But it's existing outside the two subsets, not inside the two subsets, but inside the universal. That is the meaning. Now, let's put this thing in form of diagram. Okay. Our diagram is this. We are given universal. Our universal will be outside here. That is 30. And we are given two subsets, Coca-Cola and Pepsi. This one can represent our Coca-Cola, this one can represent our Pepsi. So, they say number of Coca-Cola, that is 12. Number of Pepsi, that is 14. So, he said Coca-Cola but not Pepsi is 9. Now, let me quickly say something here. When they say number of Coca-Cola is 12, what does that mean? That means everything here has number of Coca-Cola. This cycle. I guess now. So, if I want to do Coca-Cola only, that means this place. Coca-Cola only. That means let me represent the number of, since they don't give us the number of transactions, I'll represent the number of transactions as X. So, but if I want to do Coca-Cola only, that means I have to subtract this one that enter Pepsi, side of Coca-Cola that enter Pepsi, I have to subtract it. Side of Coca-Cola that enter Pepsi, I have to subtract it. So as to have Coca-Cola only. And for me to have Coca-Cola only, I'm talking about this place, that every part of Coca-Cola, and I will remove the side that has entered Pepsi, and I will do that minus X. When I put minus X, that means I have removed the part of Coca-Cola that enter Pepsi. Now, this is number of Pepsi, that's 14. All of this circle is number of Pepsi, all of this circle. Now, for me to have Pepsi only, that shows that I have to remove the part of Pepsi that have entered Coca-Cola. If I want to have Pepsi only, I have to remove the part of Pepsi that has entered Coca-Cola. And if I want to remove the part of Pepsi that has entered Coca-Cola, that is this side, which is X minus X. That shows that this 14 minus S is what? Pepsi only. Is what? Pepsi only. Very good. Now, they said, what are we now going to find? They said we should find the number of children. Now, listen to this. If you look at this one, give it to us. They gave us the number of Coca-Cola but not Pepsi. In the question, they give us number of Coca-Cola but not Pepsi. They say it's 9. That means the people that were served Coca-Cola but not Pepsi, they say it's 9. And what is the meaning of this? The meaning of this is that it is only in Coca-Cola but not in Pepsi. It is only in Coca-Cola but not in Pepsi. What is the meaning of that? That means Coca-Cola only. That is meaning. This thing is what? Meaning Coca-Cola only. That is the meaning of this. Only in Coca-Cola but not in Pepsi is 9. Now, if you come back to this, the meaning is that this place now, it is for Coca-Cola only. 12 minus X is for Coca-Cola only. That means since I have Coca-Cola only to be 9, and I have it here to be 12 minus X, number of Coca-Cola only here is 12 minus X. What will I do? I will just equate this because this thing and this thing, they are the same thing. This is number of Coca-Cola only 12 minus X, and this thing also represents number of Coca-Cola only 9. What will I do? I'll just say 12 minus X equals to 9. Because this you see and this you see, they are the same thing. That means 12 minus X equals to 9. What will I do? I'll just collect my like times. If you bring minus X here, become plus S. If you bring 9 inside, become minus 9. That means my S equals to what? If I bring S outside, equals to plus S. If I bring 9 inside, that means 12 minus 9. That means my S, 12 minus 9 is what? 3. 3. That means X here is 3. That means the number of people that were served both Coca-Cola and Pepsi is 3. The number of people that were served both Coca-Cola and Pepsi, they are 3. That means the Roman figure 1 said we should find number of people that were served Coca-Cola and Pepsi. That's the intersection. There were 3 in numbers. There were 3 in numbers. Our S is 3. Now Roman figure 2 asks us that the number of children served at least one type of drink. One type of drink. What does that mean? What does that mean? When they say the number of children serve at least one type of drinks, that means at least, let me explain this. At least in mathematics, what does that mean? At least means that if they said, Shola, you can get at least 5. That means the least mark you can get is 5. You can also get above 5. You can get 5, 6, 7, 8. That's the meaning of at least. But when they say at most, that means when they say you can only get at most 5. That means you can get 5 below. But when they say at least 5, you can get 5 upward, 5, 6, 7. So if they ask us that the number of children serve at least one type of drink, that means you can get one above. If you look at this one, at least the Coca-Cola now, Coca-Cola only now is 12 minus x. This one drinks. The Coca-Cola only serve at least Coca-Cola only 12 minus x, and I've known my x to be 3. That means my x is 3. 12 minus 3, that is 9. At least Pepsi, for Pepsi only, that is 14 minus 3, because our s is 3. 14 minus s is 11. Don't forget, I said at least can be that number above. So what about this? Serve both, which is 3. Are you guessing it now? We also have 3 for the 2 drinks. Sorry. C intersection E is 3. So what do we now do now? We add them together. That is 9 plus 11 plus 3. 11 plus 9, that is 20. 20 plus that is 23. So that is number 2. The number of children served at least one type of drink is 23. Now, the last one says the number of children not served any of the drink. 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 When they say not served any of the drink, what does that mean? Now, let me tell you this. These two subsets, the addition of everything is union. The addition of these two subsets is union. That means in a question whereby they give us union only represents the addition of these two subsets. But when they give us universal is talking about the addition of these two and the ones inside the rectangle. And which one is inside the rectangle? That means the one that neither belongs to this one nor this. So if it neither belongs to this one nor this, it is going to be inside the rectangle. But everything here belongs to universal. Now, when it says that the number of children not serve any of the drink, what does that mean? That means it's not here. It's not here. But it's inside A. You can only get it. And how are we going to do that? I can now represent it as y outside the two subsets. Let me just put y here. Now, I've known this one x to be my 3. Now, 12 minus 3, that is 9. In this place is 9. Plus 3. Plus 14 minus 3, 11. Plus y equals to 30. I represented the number of children. They were not served any of the drink to be y. Because if they were not served any of the drink, that means they are outside the two subsets. So, 9 plus 11, 23. 9 plus 11, 20 plus 3, 23. Plus y equals to 30. That means, I'll collect like times y equals to 30 minus 23. And y is 30 minus 23. That is 7. These are the number of children that were not served any of the drink. Now, let's take another 2 more examples under this subset, and I believe it is going to be clear to us.